Hello, everyone, and welcome to the Monday afternoon webinar series from Corwin, your no-cost platform for superior professional learning. Today's presentation is Classroom Discourse that makes student thinking visible, with your presenter, John Safier. Now what I'd like to do is turn the meeting over to Charlene Maher, Executive Marketing Manager from Corwin.
Thanks, Jeff. Hi, everybody. Thank you so much for joining us today for our webinar with John Safier on Classroom Discourse that makes student thinking visible. I have the pleasure of introducing John for this webinar. John Safier is the founder and president of Research for Better Teaching, Inc., an educational consulting organization based in Acton, Massachusetts, that is dedicated to the professionalization of teaching and leadership. He is the author of several best-selling books, including The Skillful Teacher and High Expectations Teaching, his latest book published by Corwin. He has worked in education since 1979, and he and his colleagues have taught in-depth professional development programs centered on the knowledge base of teaching to educators in more than 200 school districts each year in the United States and other countries. So please join me in giving a warm welcome to John Safier.
Thank you, Charlene. Well, hello, everybody, and I appreciate so many of you taking time on a Monday afternoon to spend a little time with me. In the 45 minutes or so I have with you, I want to make it as worthwhile as possible. So I've structured it in the following way. This topic, making students thinking visible, is a subtopic of what I did in last year's webinar. That webinar was on high expectation teaching. And that topic is, hey, suppose you wanted to do everything you could possibly think of to get low-performing, low-confidence students to believe in themselves and to learn effective effort and believe that if they exerted it, it would lead to success, and that's worthwhile doing. This is a subtopic of that very large topic. And I have to say, if you were to go back 4 decades with me and say, John, now that you know what you know, what's the thing you'd pick most to learn about in your 10 years of classroom teaching? And I got to tell you, I would have picked this. So what I'd, next slide, Jeff. If you happen to have the High Expectation Teaching book, the content that I'm going to deal with this afternoon is on page 85 to 90 of that book. So if you have it nearby, it's worth grabbing. I want to point out also that making students thinking visible is not the same as the content of Ron Richards' excellent book. That book is titled Making Thinking Visible. It's 3 out of the 4 words we use. It's an excellent book, but it's about something different from what we're going to talk about today. That book is about thinking routines. Some of you may be familiar with See, Think, Wonder as a way to get kids to explore content. So valuable as they are, this is different. This is about creating a robust talk environment for students where it is safe to make mistakes and where everyone participates. We are also going to record the conference, especially, Corwin always does this, but for the following reasons. I'm going to go through in 45 minutes with you all what I would often do in a 2 to 3 hour workshop with people, and I'm going to stop and share with you how I would do it if you would wish to reproduce this content as a PD session for people using the videos that we're going to show. Okay, next. This particular constellation of skills is not exactly the same as accountable talk, but it's accountable talk. If many of you are familiar with it, you'll see elements of that show up here. It's accountable talk to the max. So if that happens to be a topic you've been dealing with in your districts, this will provide you some material for augmenting and adding on to the skills that people have in that. And if you haven't been doing that yet, this will be a good way to introduce it. Next. The reason that this topic fits in with high expectation teaching is it inherently creates a climate for kids where they are called upon to do high-level thinking and the environment is made safe for them to do it. And everybody is going to participate in that. There are other strands. Hit the next 5 buttons, Jeff. There are other strands that are inherently part of making students' thinking visible because everybody gets to do high-level thinking and everybody has to participate, high student engagement. And the other strands you'll see are brought into social and emotional learning in the context of having to direct teach some of the social skills that make conversations productive amongst kids in groups. Next. So what we're going to do this afternoon is I'm going to lay out the 24 operating principles or moves of making students' thinking visible and show you what they look like in operation. And then, because nobody can take on learning 24 things that are part of a constellation of skills all at once, I'm going to highlight the first ones that are appropriate for people to work on developmentally if they're just getting into this. Righty, next. Students are producing first bullet, evidence-based talk at high levels of thinking when this is working, and they are beginning to take more and more responsibility for their own learning. Another outcome is that the kids are taught to and explicitly listen to one another. And it happens in a climate of mutual support and non-defensiveness. That's where the classroom climate building part comes in. Next. So what you see is, next slide. Oh, sorry. Students talk more than teachers do, and I had already made the point about accountable talk. When it's working, and I'm going to ask you to look for these things in a video clip we're about to look on, you see students do the majority of the talking. They're always asked to elaborate their answers and explain it, and they do. They prove they're listening to one another, and they're willing to openly admit confusion or not knowing something. They will challenge each other's thinking, but not in the sense of, oh, you're wrong and I got the right answer. It's a non-judgmental exploration of what the thinking of the student was. That especially happens when one kid begins to see where the other kid went wrong and explains or hypothesizes about what the other kid might have been thinking. I'm going to show you a clip, and we'll go to the next slide now. It takes place in a classroom in District 2 in New York City. Now, District 2 went from below the middle to the #1 performing district in the whole of New York City in the years 1990 to 1997. And you could have walked into any class, any school, any grade, any academic subject, and seen the kind of conversation going on that we're about to see in this clip. So there's got to be something going on here. That's not the only thing District 2 did, but it was a very important part of their success. So, next slide. You're going to see Debbie Altenow doing the border problem, which is something in the investigation curriculum. And the kids are going to be asked next and next. If they went to Home Depot and wanted to buy tiles to put around this swimming pool, how many would they have to buy? The swimming pool, you're looking at an aerial view. It's 5 by 5. And the border is going to go on the ground around the outside of that pool. It's not going to go on the inside wall. It's on the outside. You could walk on it. So how many tiles would you have to buy? Now, at this point, if you're going to do this as a workshop, stop and let people come up with the answer before they view the video. Otherwise, they'll spend the video watching time trying to figure out the answer. So I'm going to give you all, and if you happen to be sitting with people, talk about this with them for 30 seconds. What do you think the answer is? How many tiles? Think about it for 30 seconds. Go. Now, when I do this with people, I go around to groups of tables, and I'm trying to model a few of the moves out of Thinking Visible. Like, for example, I won't validate any answer as right or wrong. If a person gives an answer, I'll say, what do you think, to the person next to them? Or I'll say, do you agree or disagree? Or what made you think that? Who is it? And I try and find especially two people with different answers and get them to talk to each other about how they came up with it. Now, the answers that I get from any audience, big or small, of the following range. I get 20, 24, 22, and 29. So you can see if adults are finding this a little tricky, the kids might too. Next. So skipping all of the interaction you'd have with people at this point, this is the answer. 24 slides, 24 tiles. And the tricky point is obviously the corners. People are liable to think, oh, it's 5 by 5, 4 times 5 is 20. And in the video, you're going to hear a kid say that. 22 and 29 are wrong, but I actually have had both of them be right. One time, a guy who said 22 said, and I think this guy's a little cheap, he said, oh, I'm going to take one of those corner ones, and I'm going to cut it in half in the diagonal. That'll give me 4 little triangles, so I'll put them there. Another guy was in the construction business, and the reason he said 29 is he said, oh, well, there's going to be breakage. You got to buy extras. I had to shake my head. Yep, good thinking, buddy. Now, Debbie's doing this as an activator with her 8th grade math students. It's an activator for a later activity where they're going to have to make up an equation with a variable in it that would allow them to calculate the number of tiles for any pool that happened to be in the shape of a square. And later on, she's going to have them make up another algebraic equation to find the area of it. But right now, she's just going to have them talk about their answers to this. Next slide. So I want you to look at the video. It's a little less than 5 minutes long for these 3 things with the check marks. What do you notice the teacher doing? What do you notice the student doing? And I'm going to cue you, because we're a short shift on time today, next slide, to look particularly to these things. You'll notice that they're all facing each other in a circle, or an oval. What's the significance of that? Number 2, from the teacher, she will always ask every student, no matter what they say, to explain their answer. And then there are some normal prompts that will recur often. Do you agree, disagree? She'll ask one kid to comment on something the previous kid said, commenting on other ideas. And she will use the language of thinking, not the language of right answers. You'll often hear her use the word thinking. Say, can you explain the thinking that led you to that? Or how is the way you're thinking about it now different from the way you were thinking about it before? You'll also see evidence of 3 and 5. That is, students will decide to appear in the class without having to go through the teacher because they want to talk about the kids' thinking. And finally, Mike is going to give a wrong answer. And number 4, you're going to see her go back to Mike when all the class discussion has taken place. And that is a frequent occurrence. So we're going to look at that first video now, Jeff. And then we're going to come back to this slide, and I'm going to ask you which of these things you think we saw. Off we go.
Going to look at a problem in which we have to put a border around a pool. We have to figure out how many tiles we would need to put a border around a pool. So what I wanted to start off with is a pool with length of 5. The pool is in the shape of a square. And can anybody tell me how many tiles you would need to put a border around the outside of this pool? Lulu?
I think you'd need 24.
How'd you get that?
Because you need 4 tiles for each, you need 5 tiles for each side. And then you need 4 for all the corners.
Okay, you want to come to the overhead and use some of the overhead tiles to show me how you were thinking about it? What do you guys think about what Lulu said? Do you agree? Do you disagree? Mike, what do you think?
Did you say 24?
Did you say 24?
Yeah.
You disagree? What do you think?
I think it's 20.
You think it's 20?
Yeah.
Why?
Because 5 times 4 is 20.
Okay. What do you guys, let's comment on what Mike said. Leah, what do you think of what Mike said?
Lulu also said they had to have the tiles to put on the corners of the thing, so that equals to another 4 tiles to 20, and that makes 24.
Did you get that? So what's different about what Leo said than how you were thinking about it?
He added the corners.
Aha. Tiffany, something to add?
Mike, why didn't you multiply 5 by 4? How you got 4?
Because there are 4 sides. 5.
Yeah, but wouldn't you multiply like length by width?
I'm saying? You have a comment, Mike?
That's what I just thought that you were thinking of finding area or something. I don't know. Something like that.
Yes, Mike?
When would it be 25 and there aren't 5 sides, there are only 4 sides?
So Tiffany's bringing up the idea of area, length times width. Were you thinking of area?
I guess.
You think you were, but you just said that area would be 5 times 5 would be 25.
Yeah. Oh wait, no.
Keep thinking about it, okay? I think you were thinking about something that we're going to talk about anyway, so see if you can make a connection. Does anybody else have a comment on the number of tiles you need? Oh, Lulu, you're doing exactly what I hoped you would do. Look how she's setting this up. Amber?
She's put in the 4 corner squares in different colors to show that the 5 tiles on each side, representing the 5 for each side, plus the corners.
So what do you think when you're doing this question, what do you think is the part of the border that people might forget? Pascal? The corners. Why do you think people might forget the corners? Claire?
When you look at the drawing, you only see what's inside, and you don't really think about how to create the outside. So you only think about what's inside the square.
What's inside the square in this part?
Yeah.
Okay.
You think about like the outside, but you don't think about if you were to actually create a border, and then you just think that it would be the way it looks or appears, but you don't think about how you'd actually create the outside.
Okay, who wants to add on to that idea? Chloe?
I think people think more about the perimeter,
Aha.
and they don't include the corners, because when you count up a perimeter, so I think people like take border and put it with perimeter and don't include the corners, because when you think perimeter, you only think how many units across and down and how many are around it, surrounding it, not...
Can you connect your idea about perimeter to something somebody else in here already said?
Mike.
Yes, Mike, go ahead.
He wasn't including the corners, I guess, because he figured if you were just going to border the sides of the... Is that a pool?
Yeah.
If you're just going to border the sides of a pool, you wouldn't include the corner because you don't count that in perimeter.
Okay, so Mike, does that clarify for you what you were thinking in the first place?
Yeah.
So which measurement were you thinking of?
Just 5 times 4.
Which is equal to the area, the perimeter,
The perimeter.
Okay, the perimeter. Lulu, would you fill in here the number of tiles needed to border the pool? Just put in the number. So is everybody okay with this? Does anybody have a problem?
Now, folks, if you're doing this as a PD session for folks, at this time, I haven't given them the slide I just showed you of interesting things to look for. What I said was just look for anything you think is interesting or significant about what's going on in this classroom discussion. And we have cued them that this is something that goes on all over the district, and the district has been very, very successful in student achievement. And so people will come up with maybe all of these things. They don't always come up with, oh, there's no judgmental language. And the teacher is making the students do the work. They're doing the majority of the talking. What people will often say is, there is a climate of trust and safety amongst the kids. I wonder what she did to create that. And the answer to that is they did not go on a ropes course in the middle of the woods for a week before school started to build trust. They don't have a social-emotional curriculum. This is quite a while ago. All she did is what you see in that clip, except that she's done it from the first day of the year. And so have their other teachers. So this climate gets built over time. At the very beginning of the year, you wouldn't see so much active interaction amongst the students. But what we get here is a picture of the end state that really is doable when kids have this environment around them. Now, as far as the things on the video goes and the things that are on the slide here, you definitely see the girl in the red shirt, whose name is Tiffany, saying, Mike, why did you multiply 5 times 4? And it's not a judgment, Mike, that was a stupid thing to do. It is, I wonder what your thinking was that you did that. Actually, she's curious about his thinking, and that becomes a characteristic of these classes. So, in the next slide, Jeff, you'll see some quotes I've excerpted from the video backing up the presence of the items that we just looked at. The second one, so Mike, what's different about what Leo said from how you were thinking about it? That's a typical quote where the focus is on the thinking. What it comes from is, as a teacher, I have that intention. You know, I'm going to lay out in a minute what the 24 different kinds of moves are that people make. But if you form the intention, if I form the intention as a teacher to continually get the kids to talk to one another and be curious about what they have to say, the moves start to flow very fluidly. It's not like I'm going to memorize 24 moves. The next slide, you do have the layout of what they are. The beginning of this kind of classroom discussion is always coming up with a good question, something that will cause the students to think, you know. So we just read the chapter about the motives of the South in the Civil War. Do you think the author got them right? These moves are not math limited, even though it happens that in this country it was mathematics educators that originated them, people like Magdalene Shifter, Deborah Ball, Magdalene Lampert. They apply in any academic discipline. They are just as useful in social studies and science as they are in mathematics. I just wanted to clear that away in case any of you were beginning to think, yeah, but what would it look like in social studies? Number 2 through 5 are things that we do as teachers to start creating the safe environment. Number 5, validate confusion. You know, so take your time on this. It's a tricky one. It's a tricky one, Jamil. Avoiding judgment, of course. Everybody's going to get called on. They didn't in the brief clip we saw, but they're going to. 6, 7, and 8 are starter moves I'll go into more later. You may be very familiar with turn and talk. But the habit of never moving on without asking a kid to elaborate is not one that all of us have. And number 8 is, I will often ask a student to restate what another student said in their own words. 9 through 13 have to do with helping students realize that struggle and difficulty is to be expected, as are errors. They are normative. They are also useful. And you saw her do number 13, come back to Mike, at the end of that last one. Now, what's intriguing is that there are certain habits that many of us have that I've got to give up. I've got to give up my press on speed to cover, because what you're going to see in the next 4 minutes is she's still on the same problem with the same kids, and you stay a long time on singular topics in order to get depth rather than just breadth. And she won't jump in and save a kid who's struggling. She'll support and scaffold the struggling, but she won't answer herself. Next. Next slide, Jeff. Number 18 through 22 are things the teacher will do to get the kids engaged with one another. Number 20. So how's the way you're thinking about it now different from the way you were thinking about it before, or different from the way that Maura's thinking about it? And then we won't see these or get to them today, but 23 and 24 are that this constellation of skills is very much invested in using academic vocabulary, recording it, and getting the students to use it. That's why we may be pushing things beyond some of the standard moves in accountable talk. Now, if you do this with participants in a study group or in your school, this is a time where I wouldn't cue them what they're going to see. I'd say, write down any quotes you hear, either from a kid or from a teacher, that you think are interesting or significant. We show the clip. I'm about to show it to you. Then we say, all right, in your tables, person who goes first, read your quote. Don't say what you thought about it or your opinion. Just read the exact quote that you took down, and then say why you picked it. And then you go around the table, and everybody does that. After that is where I'll put up the slide with all of the 24 moves on it and explain them. because what we want to do is get people using their own antennae to pick up what they think is useful here, rather than trying to match what they hear with a checklist of moves that have names. It's useful to have the names, but the most important thing is to get people to notice what's important and to invest in trying to understand what a teacher does to make this environment happen. You could also then do this exercise in the black section on the right of this slide. It's a good time to pause and have every individual do those 3 steps. How often do you use any of these moves and which ones in your own conduct of classroom discussions? And do you do them sometimes or significant or not yet? You know, this is just a little personal self-assessment. Now, next slide, please. What she's going to do with them next is she's going to say, okay, we've just figured out what the border is around the pool. Next. Now, what's the area of it? Just the blue part, the pool without the border. And then she's going to say, next, what's the area of the whole thing, the pool with the border? Now, once again, give your participants or your study group a little time to figure this out. And this one won't be as tricky as the last one. You know, there's 3 ways to do it. There's the slow way. You count the rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the fast way. Oh, multiply length times width. 1, 2, 3, 4, 5, 6, 7. 7 times 7, 49. And you'll see a girl in the class who says, well, I already know it's 24 red ones. And the middle is 5 times 5, 25. 25 plus 24 is 49. You know, multiple ways of doing it. But what we want to do now is see what happens when a kid answers incorrectly. She's going to call on Kristen, and Kristen's not going to say 49. He's going to say 36. So we get to see in this clip, which Jeff will start at 124, how errors are handled. All right, so let's go to that clip, Jeff.
So I want to just clarify some of the things that we've already sort of gotten into. What's the area of, Lulu, would you stay and just continue to fill in these things? Thanks. What is the area of the pool? Not the pool with the border, just the pool. Adam?
25.
What do you guys think? Put your hands up if you agree. Anybody disagree? You want to, can someone, Adam, why don't you explain how you got that?
Well, you're asking for the area of the pool, and area is length times width, and they're all the sides are 5, so you do 5 times 5 equals 25.
Okay. We agree? So you want to put that in? Does it matter which one we call the length or which one we call the width here? How come? Remy?
They're all the same size, so it's just like side times side.
Excellent. It's just like side times side. Okay. How about the area? When we write area, what do we have to put? If we just write area of pool equals 25, is that 100% correct? What do we need to add on?
Centimeters.
Are we in centimeters? Do we know what we're in?
No.
So what could we say? What could be a general thing we could say? Natalie?
Units squared.
Let's just put units squared. Good idea. All right, how about the area of the pool with the border? So the area of the pool and the border together. What's that going to be? First of all, is it going to be greater or less than the area of the pool? Uh-oh. Is the area of the pool with the border going to be greater or less than the area of the pool? Kristen?
Greater.
Okay. So now what's it going to be?
36.
How'd you get that?
Cause I counted the amount going down and the amount going across on the border, and it was 6.
It was 6?
Yeah.
You want to
so-
come up and count for us?
No.
It's okay. Let's watch and see if
Oops.
what'd you get?
7 and 6.
7 and 6? Okay, let's think about that again. Show us how you're counting. Point to each square that you're using and count out loud so we can hear you.
1, 2, 3, 4, 5, 6, 7.
Okay, so let's stop right there. The length of this side on the top is 7 units, right? Now you want to take the length of this side?
1, 2, count, start from here.
What do you think? Is that part of that side?
Yeah.
Okay.
1, 2, 3, 4, 5, 6,
So what's the length of this side?
7.
So how are you going to find your area? If you need help, you can ask somebody in class.
Would it be 49?
What do you guys think? Would it be 49? Okay. So you want to tell us what you did the first time that was different than how you figured it out the second time?
Oh, well, when I was looking on there, I guess I got mixed up. Like, I counted 1 yellow for 2. Like, from far away when you count and sometimes skip.
Okay.
So I guess I skipped a cube.
Okay, so you just miscounted. You just
Yeah.
skipped one? Okay.
And then I didn't count it this way, but then I didn't count this one for going this way.
Aha, so you only counted one side of this red corner one, not the other side of it when you were going down?
Yeah.
Okay, thanks, Kristen. Natalie, do you want to add on to that?
Yeah, I got the same answer by adding 24 plus 25 because you knew that there were 24 tiles around the square of 5 by 5.
Yeah.
So 25 plus 24 is 49. So I agree with Kristen.
Where'd you get the 24 from?
The 24 is the number of tiles around, like the border around the square in the middle.
Ah, what do you guys think of that? Can somebody paraphrase Natalie's thought? Say it in another way clearly. Claire?
Natalie found the outside of the inside pool, and then she took that, and that was 24. She counted the number of tiles, and she got 24. And then she took the outside amount of tiles needed to build the outside pool border, which was 25. And she added 25 and 24, and she got 29 and 49.
Okay. Shayna, did you want to say something about that? I thought you had your hand up before, no? No? Okay.
She answers my question.
You go ahead, say it your way.
No, I was just gonna add why Kristen would have miscounted, but
Go ahead.
no, it's okay.
Okay. All right, so we figured out, yes, Tiffany?
Okay, I have a question. With the since you know that the length and the width are the same, 5 and 5, would you still use that to see if they were the same? Like since the length with the border 7 and 7, because he put 7 and 6, would you still use it to think that it's the same length and width?
I'm not 100% sure.
No, because he made a mistake. Kristen made a mistake and said that the length and width were 7 and 6.
Yes.
He could use 5 and 5 just to say that the border would still be the same length and width, 7 and 7.
Mm-hmm.
So, okay, it's hard to explain.
Do you want somebody to try to add on? to what
Yeah.
you're saying?
I think that what Tiffany is saying is that you know that the pool is a square, so, and that since it's a square, the sides are all the same, 5 and 5. And so you know that if the pool is a square, then the tiles would have to make a square too. So you'd know that the sides couldn't be 7 and 6, they would have to be 7 and 7, or like a number that's the same.
Okay. Is that what you're saying?
Yeah, so he couldn't have made the mistake.
Right. 7 and 6, you should have thought, well, it's a square, so both the numbers have to be the same. Can I go back to Natalie's way for a second? I think I just finally figured out what you were talking about. You were saying that if you know the number of tiles you need in the border is 24, and you know the area of the pool is 25, you can add those two things together. How did you know that the number of tiles in the border was the same thing as the area of the border? Because in order to add them together to get the total area, you have to think they're both area.
Right, well, I sort of looked at the diagram. It's filling up a space. It's taking up a space. So it was taking up that area of, like, the border.
So each square has a measurement of what?
1 unit.
By?
1 unit.
1 unit by 1 unit. So one square here, one tile, has an area of 1. That's an excellent strategy that Natalie came up with. When you're going to do your group work, I want you to keep in mind this idea of dividing the area of the whole into different parts and seeing if you can do anything with that.
You get what the point is she's trying to make, folks. It's probably the best mathematical insight of the class. She's saying that if you border a square, the square has equal sides, and if you put a border around the outside of the square, that's going to make a new square that'll also have equal sides. So if you have 5 and 5, then whatever you're going to have for the two sides to multiply has to be the same number twice. By the way, if you heard a big bang there in the middle of that clip, that's because the cameraman knocked over a desk. Best laid plans of mice and men, you know. That's what that bang was. So a lot of interesting things in this one. What I'm asking people to do in the session, if we have a study group or a PD session on this, is to go through the list of 24, which was introduced, which I'm going to introduce actually after the clip, and to identify how many of them appeared. But first, we're going to do that other activity where they take the quotes they wrote down and they go around and say what the quote is and why they picked it. Every group is going to get the one where she says, Kristen, what's different about the way you were thinking about it now from the way you were thinking about it before? Not everybody will pick up the fact that if you're humiliated or embarrassed in front of your classmates, it's pretty sure you're going to freeze and not be able to think much. But when asked what the 7 times 7 is, Kristen is at a loss to come up with 49, and Debbie says, if you want to ask for help from somebody in the class, you can. Does he ask? No. He sticks with it, and he gets it. So he's not closed down. And once again, people are going to say, how did he get this climate? You do these moves, and you do them authentically, and you create this climate. There are some things involved, like explicitly teaching kids some of the norms and the social skills that are involved in having good conversation, and being explicit about what you want, what you're doing this for, why it is important we be a community of thinkers and learners together. And the next clip I'm going to show you is about that. That is to say, especially in secondary school, if you're introducing this and going to be doing it with people and they're not used to it, it's really useful to explain to the kids what your motives are. Otherwise, kids might feel put on the spot when you say, oh, John, can you restate what Maria just said in your own words? It's not a gotcha game to catch you listening or not listening, although it is going to encourage kids to listen because they know you might do this. It's in order to hear the explanation and the thinking from multiple points of view. Next. Now, after folks have done the round table in which they've shared the quotes, and let's go to the next one after that too, Jeff. Then I'm going to go through the 24 moves, and I'm going to say, how many of these and which ones do you think showed up in the class we just saw? And when people go through them, they're going to find, yes, indeed, quite a few of them were there. But it's not a matter of the right answers. Let's make sure we guess them. It's a way of making people go back to the definitions of what these things mean and compare it to what they actually saw. So it makes them revisit what the 24 moves are. It's not an identification game. How many can you guess right? It's force you to revisit the meaning of these 24 things. And for the doing of that, you need to have those pages that I identified or something else that defines in a paragraph with some examples what each of these 24 things means. That's what is on 85 to 90 of the High Expectation book. There are some embedded values, next, that are characteristic of the people who are doing this kind of teaching with kids. The first one is curiosity. You know, you really want to know what's going on inside their head. And the second one is social interaction. That is, you believe that, as Vygotsky said, Learning takes place through socialization, social interaction, academic talk. And the more you get the kids to talk their thinking and have them talk to each other, the more you're going to get the learning to happen. The next value that's embedded in this is safety. This has got to be a place where it's okay to be stuck. And we expect that to happen, and that the stuckness and getting unstuck is, and as well as struggle, something that's useful for us all to go through. The fourth one is respect. We're building an environment where kids respect another kid's wrong answer, having been created by some kind of thinking that has a legitimacy behind it, even though there may be a gap or an error in it. And the last one, of course, is we are interested in the kids understanding this academic content. That's why we do what we do. All right, so let's push on through the next slide and show the picture of Jen, Jeff. This is Jen Bowler. Like Debbie Altenow, Jen eventually became an academic coach in her school, which is a high school, Evanston Township High School, particularly for making students' thinking visible. And so what we're going to see here is just a couple of minutes of what she did the first day she was going to use these behaviors with students. So let's run that video now, Jeff.
Okay, so today I'm going to give you an introduction to what making thinking visible is all about. We've been doing it in little pieces throughout the year. If you've ever noticed that I'll give you a heads up when I'm going to just cold call and just call on people, that's sort of the start of it, where you might not know that you're going to be asked to answer a question, and then I just call your name, and you have to try it, and you might not, I probably usually say, you might not know the answer, that's okay, we're going to work through it. That's kind of the start of making thinking visible. Basically, in this method, the teacher, I will call on you kind of randomly, go around the room, and I might question you again about the same concept to get you to say it a little differently or even add to it and get you to say more about it. And that's not to make you feel like I'm picking on you or drilling you. It's to get you further along in your thinking. And then I might say, if I was questioning Julia about something, I might pop over to Isabel and say, Isabel, do you understand what she's saying? Can you restate it or rephrase it in your own words? Or if perhaps what she's saying is one way of doing something, I might say, Isabel, is there another way to do this process? So I might pop over to someone else to reiterate something that someone already said, rephrase, or tell a different way of doing it. And then I might pop back over to Julia after that and say, can you explain what she just said? So don't be surprised if I come back to you. It's not that you were necessarily wrong in any way. I just am checking to see if you're understanding and if you can explain things in your own words. Hopefully by doing this, you're hearing what other people are saying, you're listening to other people, and when you're asked to answer, you're actually understanding it more and more because you're forced to really think about the material. A lot of times if someone's answering a lot, you might shut down if you're not someone that's answering. So I just ask that you listen to one another. If you hear a fellow student struggling, you could certainly say, Isabel, I think I know what you're saying, but isn't it this because something else you might add to it? And then I'll say, Isabel, do you understand what Sonia was saying? So there's going to be a lot of popping around. That's something that might be a little bit newer, where I ask repeated questions of one person and then maybe pop back to that person. Okay, so don't be surprised if I ask you to restate something someone says or add to it, and then if I come back to you to restate something. Okay, and this is all hopefully an environment where you feel comfortable sharing. And again, if you don't know the answer, that's okay. I want you to be ready to try. And if you're stuck right away and you'd say, I really don't know, that's okay. But I might pop to someone else, and if they're kind of on the right track, I might pop back to you and say, okay, can you now explain it? Because really, the point is that you'll learn the material in this method or through this method. Okay?
One person who is good at these skills can open their classroom to others. We call it the collaboration teacher model, and invite them to come in. Or you can have 3 or 4 people who are working on this and get good at it, and then have them present to the faculty or the department what it is they've noticed their kids are getting out of it, and then the principal sets up a visitation schedule for those who are interested in it. What we call the collaboration teacher model is a really nice low-key, low-voltage way of getting teachers to be champions for these ideas. So we're getting close to our end, and I want to leave a little time for questions. There are more videos in the High Expectation book with little QR codes next to them. That's another resource, and there are also some others on the rbteach.com website. What I'm going to show you now is a single clip in which Lucy West and I explain why the 3 starter moves are the good ones to use, and then we'll show a little bit more of Jen using them with her kids, and then we'll go to Anthony's class, elementary class in Mamaroneck, New York. And then we'll wind up and have some questions. So what I'd like to do is just go to the next slide for a second. These are the names of the 3 moves that we're going to be illustrating in this video. Explain, explain, explain. That's always on my mind as a teacher. Whatever a kid says, there's going to be another go-around with them. Now, by the way, I have to therefore ask a question that's explainable rather than a factual question. Doesn't mean you never ask factual questions. It's just that you try and salt the dialogue with questions that might create different explanations or different points of view. So let's look at that last video and then get ready to wrap up. The reason I'm showing you this video is that it is a fruitful place to start in what is a developmental sequence. It's a period of time, depending on how ready a person is to give up old habits, like me. Saving kids was a habit I had to give up. Oh, I know how to explain that. Let me jump in and explain what you're struggling with. No, John. You got to get the kid to explain their thinking and then try and create some interaction between that kid and kids around them. So let's go to that last clip, Jeff.
We believe that the first 3 talk moves are nameable and practicable, and that real change takes place by actually practicing specific behaviors. So the behaviors are turn and talk. The idea is you're supposed to get 2 kids talking to each other about the idea that's on the table. 2, no matter what a kid says, whether they're right or wrong, whether the answer is the one you're looking for or not, you say, tell me more about that. How did you get that? Why do you think that? Anything to draw the student out to give you a complete idea. The research shows that presently, in most classrooms, when a teacher asks a kid a question, the kid answers, generally, in 1, 2, or 3 words in 3 to 5 seconds. So what does that tell us? It tells us that the kids are not thinking, they're not answering in complete sentences, they're not developing language, that it's a rapid ping-pong kind of way of marching through a lesson. If you want kids to think, communicate, and go deeper, they need to learn to speak in full ideas, and that generally requires a couple of exchanges. So you give me an answer, whether it's the one I want or not, I ask you more about your answer.
So talk about what you're doing right now. Max, what are you doing?
Well, what we're doing is making 30. This is 30 right here, represents 30. Okay. It's not 30 discs, but, and we're multiplying that by 3. We're making 3 groups of 30.
I like how you guys are working as a team, too. Seems like you guys figured out a good system.
Hundreds of
And why are you making 3 groups?
Because we're multiplying this 30, this number, by 3.
Okay. And how do you know to do that? Where does it say to do that?
Right here. You might not be able to see it, but it's clear here.
What about that tells you to multiply 30 by 3?
Times 3.
Oh, so where's the 30?
This
Where's
is
the 30 over here? What place is that?
The tens.
The tens place. Good.
Step 3 is to say to the rest of the class, who can respond to, who heard what was just said and can repeat it, can paraphrase it, can summarize it. That works on the listening side of things. It also gives weight to students' voices.
Early on, I had a tendency to ask the question, let a student answer, and then ask another question and let another student answer, and just kind of pop around in my old way of asking questions. The improvement was I was asking new people for answers. So then with more practice and with some coaching, I was able to maybe start with a student and ask a question and ask maybe another student to reiterate or restate that same question, and moving towards getting to the point where I go back to that original student and check if they understand it now and ask them to restate it.
So let's get started with the conversation. The what is a hydrate question. From the lab and maybe from your reading and notes, what did you think about what is a hydrate? Let's start with Brittany. What is a hydrate?
It's an ionic compound in which the water molecule becomes part of a crystal.
Okay, so how did you know it was an ionic compound?
Well, for example, Na2B4O7 is has a nonmetal and a metal, which is an ionic compound.
So let's see, Erin, since you're right there, would you restate that? Why is the ionic, how do you know it's an ionic part with a water part?
Because there's a metal and a nonmetal bonded to a water.
Okay, so we've got our metal and nonmetal bonded to a water. And Brittany, back to you, how did you know that it was the metal and nonmetal? What were you using to figure that out?
Oh, I was just looking at the periodic table. Okay. Like the Na is in group 1, so it's a metal.
If you want to encourage students to make their thinking visible, you can't ask questions that have one-word answers. There's simply not enough information you can get from that. And I've seen this with newer teachers where they ask a question, they get the answer that they expect to get, and then they think, oh, this student understands it. And then with a few more prompting, or they find out, oh, they actually didn't understand it. And so we really don't get much information from these very, answers requiring very short, or we don't get very much information from these questions that require short answers. And so the types of questions you ask, like who's willing to explain what they're thinking, or who's willing to share a few thoughts on this, or do we agree with this, why or why not, require students to articulate at a much deeper level their thought process. And in doing so, we better assess where they're at with the content objectives.
The overall objective of this webinar was to generate interest in those of you who are participating in going deeper into these skills if you're already in it, or beginning to learn about them if it's more new for you, and to provide you with materials for doing local PD, either with small groups or large groups. For those of you who are administrators, if you are interested in pursuing this with teachers, I would strongly urge you to practice the skills yourself in their classrooms and be seen visibly to do that. That is one of the best trust builders that a leader can do. Be seen as and authentically be a learner with one's staff members. So we got a little time left, and of course with the number of people that are on, we can't be as interactive as I'd sure like to be. But I would invite some questions now, and the ones I don't get to answer, we'll create a way to do that online, but off and outside the time boundaries of the webinar. So Jeff and Charlene, thank you very much for your help up until now. You want to take over to get some questions?
Well, hi, John. It's Jeff, and I have one question has come in. So I have one question. With regards to social interaction, how can you use this for adult students?
Exactly the same as you saw. In fact, I do. There's 20 of us at Research for Better Teaching that do workshops and courses for teachers, and we modeled the use of it. But like you saw Jen Bowler do, we explain why we're doing it, and that it's a self-conscious part of climate building and community building.
Terrific, John. That's the end of the questions right now.
Okay. Can people send them in to you later on if they want to, and have you forward them?
They can. I have one more if you'd like it. Do you have
Sure.
students assess their own ability to make learning visible?
Well, the people that you saw don't do that, but you could convert those 24 moves into an observation instrument and have somebody in the class keeping track of the ones that are kid-oriented. That is, did anybody in our discussion today ask a question about another person's thinking? Mostly, though, I use it for peer observations. That is, two of us decide, I'm going to practice it today, and I want you to come in and listen in for 20 minutes and check off the ones that I did. And if you can, please write down what you heard me say or what you heard a kid say that made you say, oh, yeah, we got evidence for that one, John, bringing up discrepancies and having the kids sit with it. Yep.
Thank you, John. That brings us to the end. I can turn it over to Charlene now, if you'd like.
Sure.
All right, great. Thank you so much, John, for the presentation and for sharing all these resources with everybody. Just want to let everybody know that you can learn more about these instructional strategies and classroom strategies in John's latest book, High Expectations Teaching, which is available from Corwin at corwin.com. This book includes dozens of videos, links to videos via QR codes, as well as detailed step-by-step guides on how to implement these strategies in your classroom. As a thank you for attending this webinar, we are offering a 20% discount that you can see on the screen there. And this discount is valid at www.corwin.com. We will include this discount in the post-webinar email follow-up for your reference. And then you can get a free poster that lists all 50 strategies from the book when you order 10 or more copies at corwin.com.
Well, I guess that wraps it up. Thank you all for attending, and thank you, Charlene and Jeff, for your help. Pleasant evening, everybody.
Great. Thank you so much, and have a good evening.